And we're back with more compound inequalities and absolute value expressions involving inequalities and equations. So the first one is one I would try as a warm-up if you've already looked at the first video and done a bit of your homework. So the key to doing number one, or any absolute value equation or inequality that has distracting information or numbers around it, is to first get that absolute value part by itself. In other words, isolate the absolute value first. That's a big thing you guys should write down in your notes. Isolate the absolute value first. Okay? That's a really important little thing because it's not going to just apply to absolute value equations and inequalities. It'll apply to radicals, logarithms, almost everything that we'll see in our library of functions this year. There'll be special techniques to do each one, but you always want to isolate that thing before you apply whatever techniques there have been shown. Okay? So that's a general rule. It goes for like everything. So what do I need to move, guys? What's in the way? The 3, yes? Anything else in the way of the absolute value? The -4. Which one would probably be easiest to move first? 3. How do I move it? Good. All right. I think a lot of people did that. So like, people didn't do that. So that cancels out here, right? So you get 8 minus 2y minus 4 equals -3. And then the -4 is in the way, so you add it, right? And now it's isolated. Now you can split it into 2 pieces. You could draw it like we did yesterday. This one's a little bit complex, so I'm just going to do the quick algorithm, right? So I write it down. Just drop the absolute value. That's going that way. And how do I say go the other way? Make the 1 negative. Solve both, and you'll have your answer. Easy from here. -8 minus 8. 2y. It's -7, divide, so y is +7/2, otherwise known as 3.5. That's what a whole bunch of people just told me. I don't think anyone told me this. Yeah. So the other answer is y equals 9/2, otherwise known as 4.5. Cool. A lot of you are very close, but I don't think anyone had that.
I got it from you. Just after you said it.
Good work. Good work. But how long should this take you to do once you've actually practiced? Not that long. Okay. So let's try another one, number 2. Can you guys help me? I think we did one just like number 2 yesterday, really similar. Can someone read that to me? Any brave souls? Nielsen?
Distance from -2 into x is greater than 5.
Perfect. He said the distance between -2 and what we want, the x, is going to be more than 5. Now I rephrased him slightly, but that's basically exactly what he said. Well, where's this -2? I don't see -2.
It's showing.
Yesterday we learned distance is minus, so how do we get there to be a minus in there? You got to say minus a negative, right? So first you got to think about it like this. He did that without even writing it down. Very good. And this says the distance between what we want, x, and -2 is more than 5. We could draw that, so I'm going to draw this one since it's pretty simple. Good for you guys to try that on a few of yours as well. Depends how well you want to do. Depends if you want an A. So I think 0 is here, -2 is here. How far are we supposed to go from -2? 5? We're supposed to be more than 5. So I'll start out by just going 5. Something like that. I'll say that that's 3, right? And 5 this way is going to be -7. Open or closed circles, ladies and gentlemen? Open on both edges, right? Because there's no equals there. And I want to shade more than or less than. Gave it away, right? More than is that way. Less than would be that way. What do you guys think I call this? As soon as you look at this, immediately it should jump to your head that this is what kind of interval?
Or.
It's an or interval? Wonderful. What else? Yesterday we called the less than an inside interval. This one is
Outside interval.
an outside interval. That will really help you in a variety of ways if you remember that. Okay, so I'm going to finish coloring it in because I got to go outside there, and all your final answers in this class should be in interval notation whenever we're doing an inequality, right? So the interval notation is parenthesis union 3 to infinity. That's called union, or a few different names for it. Questions? So that's basically what we did yesterday, just kind of another example, right? I want to do one more today that might end up a little bit different. If you're watching the video right now, you might try pausing it and doing this one. I'm just going to do it for my class to save time. How should I approach it though, guys? It's a compound inequality with an and in the middle, right?
Solve each one individually.
Each one individually, right? These are both pretty simple, I think. I made them come out pretty nice if I did it right. Is that 9?
Yep.
So then you divide. I'm trying to color code it for you guys.
No.
Good? So yours learn to be skeptical. It's good. And this one I can go like this, right? -2. Okay. We've done them individually like Mr. Brewer told us. Now what? Graph the pieces. Just do them separately, don't worry about it yet. -10, -3, I'm gonna put 0 up here on this number line, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm gonna make this go a little bit farther for clarity, bless you. And I'm gonna shade them both in. So less than or equal to -3, so that's gonna be a filled in circle, right? Less than. Let's do green. -10 is right here, open circle. Less than is this way again. Did this problem say and or or?
And.
So what's both blue and green? Negative infinity only up until -10. Okay, so that's the answer to this one. Negative infinity to -10. Bracket or parenthesis?
Parenthesis.
Yeah, because that's open. So I think it's a parenthesis. Now that's a little bit different, right? Remember the rule of thumb I taught you to remember is if it's an intersection, usually it's going to look like a chunk. This is not really a chunk because it goes infinitely down that way. So that doesn't always work, but it does most of the time. And man, it's a good rule of thumb to remember. If this had said or, like I could easily have just put the or symbol in here, right? How would that change our final answer? Everything would be the same until the final answer. Kaylee?
Because you could have anything from -3 to -.
Yeah, because then it could be blue or green. So
You'd have 7.
the things in both would count, but also just the blue things would count, so it'd be negative infinity to -3. Okay? Let's do one last little thing, and I think we'll call it a day. Maybe two last small things. Before you launch into just doing the algorithm where you like switch or whatever, in fact, remember that one that we had right here? It was x plus 2 was greater than, did I have 5? Remember, if you're going to do that without the picture, you can do it really fast. Like this should take like 10 seconds if you're good at this stuff. You should be able to go x plus 2 greater than 5. X plus 2, switch. X greater than 7, x less than negative. Did I do that right? -2, -2, -2, -2. I can count. Yes. Okay. And then we could graph it and we'd be done. See how fast that was?
Yeah.
That's how fast it should be for you as well. Before you launch into that though, you always want to be a little bit cautious, or at least sometimes you should be a little bit cautious. Let me give you an example of when. Here's another problem that looks really similar. We could launch into this problem with our algorithm. We could go x minus 8 is less than negative 2. What would the other half be, guys?
X minus 8 is less than, or greater
X
than
minus
2.
8 switch greater than
2.
positive 2. And we could graph that and come up with the answer. Unless you're real careful with that answer, it might trick you. Why? I'd argue you should answer this question right now. What's the final answer? And if you don't think on this level, you won't get the harder problems. So we always want to think about problems before we just launch into doing some procedure that we've learned. That's very important from now on. What kind of thing comes out of this? No matter what x value you put in, ultimately, what's going to be on the left-hand side? What kind of number?
Positive.
Positive number. So this says a positive number is less than negative 2.
It's
Can that be true?
no.
No. So what's the answer to this problem?
No solution.
Let me clarify once again for people who didn't catch that. No matter what comes out of this, it's going to be a positive number. So this says positive is greater than negative 2. Let me make that ultra clear. Here's a number line. Here's 0. Here's negative 2. Where do positive numbers live?
On the right side.
Are any of those red numbers down here?
No.
So that's impossible. So I challenge you to think about these carefully before you just jump into a procedure. And sometimes it'll save you a lot of work. It's not only going to be faster, it's going to be deeper thinking as well. So if you're lazy like me, that's something good, not something tricky. Here's another one that's kind of like that. How about that? You can jump in and do your algorithm. By the way, if you do your algorithm right and you really know this stuff really well, you'll get the same answer. It's just going to be tricky. I'll show you on one of these, okay? What's that really say, though?
Positive is
Positive, something positive is greater than negative 2.
that's correct.
Isn't something positive always bigger than negative 2?
Yeah.
So what's this?
Solutions.
And since we're in inequality land, how do we usually write infinite solutions? Just to be clear, don't we go like that? Either one of those would be good.
So negative numbers are tricky.
So be careful when there's a negative number on that side. Kevin spelled it out for you. He gave you a really good tip. Yeah, Kaylee.
Why can that one have infinite and not no solutions?
Because a positive is always bigger than negative 2. All positive numbers are bigger than negative 2 or negative 7 or negative 3.
But why is it negative infinity if it's big?
No matter what number you put in, like negative 10,000, it's going to be 2 times negative 10,000 plus 4, and then it's going to change that number to positive, and it's going to be bigger than negative 2.
I get it.
Good question. Let's just confirm this. Now, if you didn't recognize that, like let's say you didn't recognize that, remember this one's no solution. Let's have a look. We go like this, right? Switch, switch. Plus 8. Plus 8. So this one says x is less than 6. This one says x is less than 10. Oh, whoops. More than 10. Let's draw. Here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, less than 6 is this way. Right?
Yeah.
More than 10 is this way. Nothing seems to have happened yet, but we know the final answer is supposed to be what?
No solutions.
But I thought I just colored in some stuff. Why is that stuff not an answer?
It has to be and.
You know what? That's worth the prize right there. I think Mr. Nielsen just earned a prize. So I'll get you your prize in a second, sir. He said because it has to be and. Go back right here. Is this an inside or an outside interval? Inside. It says go a distance from 8, whatever distance, and then be inside of that. That's what less than means, right?
And there's nothing in those two.
That's an and statement. An inside statement is an and statement. And like you said, there's nothing in one and the other here. Nothing is shared between those two pieces. So that's why that's no solution. But that's sneaky, isn't that sneaky?
Yeah.
I think that's really sneaky. You've got to learn everything I taught you really thoroughly to answer it if you do it that way. So much easier to just look and go, oh, positive's not, less than negative ever, no solution. I don't care how you do it. But there are a couple tricky problems in there like that. I'll see you next time.